Hello students, so in this video I will cover Laurent series. So let's get started. Okay, so now suppose you are given fz, a function that is not analytic at points z0, z1 dot 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 zk. Okay, let me just write it down. So fz is not analytic at z0, z1 dot 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 zk, where z belongs to some domain. Okay, now zk belongs to some domain D. Okay, then we can expand the function fz about any of these points. So you can expand a given function about any given point at which function is non-analytic. Okay, so in this case your series is going to be sigma n equal to minus infinity to infinity cn z minus. So this series is going to be minus infinity to infinity and written like this. This is going to be written in two parts. Okay, first part is similar to Taylor series. Okay, z minus z naught to the power n. Okay, so let me call it series S1 with radius of convergence capital R. So if radius of convergence is capital R, then what can you write for this? Mod of this less than R. And then again other component of the series is going to be from n equal to 1 to infinity c minus n upon z minus z naught to the power n. So in the last video I told you, right, that power of z was not negative in Taylor series or Maclaurin series, right? But here power of z is going to be negative in this expansion. Okay, let me call this series S2, whose radius of convergence is going to be this. So for the total series, by the way, you have to find this value of small r and capital R. I have given some hypothetical value. Okay, so total function, your given function fz will have radius of convergence between what? Capital R and R. Okay, so I hope you understood this, that a Laurent series is going to be expanded at the point where function is not analytic. Okay, it will have one like a Taylor series, other component will have negative power of z. We'll take an example and we'll see. Okay, so now let me take the example. So fz is equal to 1 upon z plus 1 and z plus 2 whole square. Okay, about z is equal to 1. Okay, okay, so now you have to find the Laurent series or Taylor series expansion about z is equal to 1. Now tell me one thing, is this function analytic at z is equal to 1? Yes, of course, z is equal to 1, denominator is not 0. Okay, so about z is equal to 1, if you are within a limit, okay, then if you don't include z is equal to minus 1 and z is equal to minus 2, then this expansion would be easy and simple like Taylor series expansion, right? But where are these points? This is z is equal to 1, right? This is z is equal to minus 1 and this is z is equal to minus 2. What is the distance between z is equal to 1 and z is equal to minus 2? It is 2. And what is distance between z is equal to 1 and z is equal to minus 3? It is 3, right? So if I take a circle, okay, can I call it z minus 1 less than 2? Right? Sorry. Yes, z minus 1 less than 2. What does it mean? That means you are inside this circle. That means you have not included this z is equal to minus 1. So for this one, you can have Taylor series expansion. I am not going to cover that in this video. That you can easily do. You just have to, put into that formula or expand binomial, use binomial expansion. Okay. Now, if I say use this one, this region. So this, what is this region? Mod of minus 1 less than 3, I'm not including this point, but greater than 2. That means this distance is 2, right? Greater than 2 but less than 3. So this annular region I'm covering, but excluding this point, periphery, okay? Then till here, just before this outer circle, it would be Laurent series expansion, but for z minus 1 less than 3, it would be Taylor series expansion. How about away from it? Mod of z minus 1 greater than 3. Whole series would be expanded as Laurent series expansion, because both the points minus 1 and minus 2, less than, not greater than. Mod of z minus 3, greater than 3. That means you will include this whole point, right? Less than or equal to 3. Okay? No, greater than 3 was okay. Alright. So for this one, you have to expand this as a Laurent series expansion. So let me do this for this region. So I am going to do this for this mod of z minus 1 from 2 to 3. Okay. So first thing what I will do, I will use partial fraction and I will open this fz, and this is what I will get, z plus 1 minus 1 by z plus 2. I have it ready for me, minus 1 by z plus 2 whole square. Alright. Now you have to just convert them, z minus 1 plus 2, here again mod of z minus 1 plus 3, here again mod of z minus 1 plus 3 whole square, right? Now I am going to use the binomial. So here for this one, you are including, for mod of z minus 1 less than 2, greater than 2, fine. So mod of z minus 1, take it common, 1 plus 2 by z minus 1. This term you have to take it upward, that will give you minus sign in the z. Here you have to take common 3, because here function you have not included. That means that z is equal to minus 2, you have not included this. So function is analytic at this point. Okay. So here it would be 1 plus z minus 1 by 3, and here 1 minus 9, 1 plus 3 by z minus 1 to the power, z minus 1 by 3 you have taken common. Okay. Now just open it, power would be minus, so I am going to write it at the top. Alright, I hope you can see. So 1 by z minus 1. So this series expansion can be written as n equal to 0 to infinite minus 1 to the power n, 2 by z minus 1 to the power n minus 1 by 3, n equal to 0 to infinite minus 1 to the power n, z minus 1 by 3 to the power n minus 1 by 9 sigma n equal to 0 to infinite minus 1 to the power n in n plus 1 into z minus 1 by 3 to the power n. Alright. So just add these two series and multiply this inside. What you will get? You will get the following. What you will get? You will get sigma minus 1 to the power n, 2 to the power n upon z minus 1 to the power n plus 1 minus 1 by 9 sigma n equal to 0 to infinite n plus 4. There would be 3 by 9 you can write, so this would be n plus 4, right, into z minus 1 by 3 to the power. So this series is valid for z minus 1 less than 3, okay, because you have not included z is equal to minus 2. That means analytic, this function is still analytic, and this is non-analytic part greater than 2, because you have included the z is equal to minus 1, where it is non-analytic, not analytic. That means power of z is negative in this series. Okay, similarly you can expand for minus mod of z minus 1 greater than 3. That means you are including both the not analytic function point, that is z is equal to minus 2 and z is equal to minus 1. I am going to just write the expansion. Okay, rest you can do. So fz is going to be, for the third case, 1 by z minus 1, 1 plus 2 by z minus 1 to the power minus 1, minus 1 by z minus 1. See, now you have taken common z minus 1, and here 1 plus 3 upon z minus 1. Earlier it was z minus 1 by 3 because it was analytic. Right now it is non-analytic, right? Minus 1 by z minus 1 whole square, 1 plus 3 by z minus 1 to the power minus 2. You can write in the expansion form and be done with it. Okay, so thank you so much for watching the video. You can ask your doubt under the comment section. Okay, so thank you so much.